Okay, let's go through a little bit of this using the types of measurements and calculations we're doing for Lab 3. So in Lab 3, we are measuring the mass of a beaker before the solution is added. And let's say we get a mass of 78.346 grams. And the way that that is written, we are implying that the 6 is our uncertain digit, which would give us an error of plus or minus 0.001 grams. That would be our absolute error because it's in grams, the same as our measurement. Similarly, after we've added the water, we have 89.102 with 2 being our uncertain digit, again 0.001 grams. So since that is the before and after of the mass, the difference is due to the solution that we added. So the difference of these two numbers, 89.102 minus 78.346, gives us 10.756 grams. So that's what we get. If we were 0.001 gram uncertain about our beginning measurement and 0.001 gram uncertain about our ending measurement, when we subtract those numbers, remember the absolute errors have to add. So we add the 0.001 and 0.001, and we get that our mass of solution is plus or minus 0.002 grams. The volume of the solution we take using a pipette, and then the precision of the pipette is usually noted on there. I'm telling you that the pipette that we used was plus or minus 0.02 milliliters. So we have added 10.00 milliliters to that beaker, and the absolute error is 0.02 milliliters. So what is the relative error? What percent of 10 milliliters is the 0.02 milliliters error? So the relative error we would get by doing the percent, 0.02 milliliters over 10.00 milliliters. And that would give us 0.002 as the fraction. The milliliters actually cancel, so this is not milliliters anymore. It's 0.002 or 0.2%. So we have 0.2% error. Okay, review the mass of solution added. Again, was 10.756 grams. Now we're going to figure out the density here by dividing the grams by the milliliters, the mass over the volume. Okay, so our absolute error in that mass is 0.002 grams. Let's go ahead and get a different color. So we want the relative error. So we're going to take our 0.002 grams and see what percent that is of the 10.756 grams. So we're going to divide those, and then we're going to multiply by 100 to get the percent, and it ends up being 0.02%. So 0.02%. From up above, we're told that we have 10 milliliters with a 0.2% error. That's what we figured out in this table over here. So the density of the solution that we added, therefore, is 1.076 grams per milliliter. And the relative error we would get from adding the two relative error. So adding the 0.02 and the 0.2. Remember, when you divide or multiply, your relative errors add. So that gives us 0.22%. And 0.22% of 1.076 grams per milliliter is the same as 0.0022 times 1.076 grams per milliliter, and that ends up being 0.002 grams per milliliter. So that is how you would calculate the absolute error if you know the relative error. So when you have multiplication and division, you need to convert the absolute errors into relative errors first, and then add those relative errors. Once you know the relative error, then you can use that to figure out what the absolute error is.